So the next talk is Kubernetes the day after from Neeraj Gupta from Apsara. With that, you guys have to make a lot of noise because we have like half the people in here. So let's pretend we have everyone and make it loud. With that, big round of applause.
Thank you for joining. I'm delighted to speak at this inaugural edition of the conference. The organizers have done a wonderful job, and I'm sure that this conference will become an important conference in the cloud space going forward. I'm Neeraj Gupta. I run product and engineering at Apsara. I spent first half of my career working at large corporations like Informix at Oracle, and then second half of my career working at startups. For the last several years, I've been building a number of cloud platforms, including mobile backend as a service, Node.js platform as a service, private and public PaaS, and container management platform. So I thought I would come and share my experience with you. At Apsara, we have been building trusted cloud management platform. We allow businesses to run any workload on any cloud platform in a trusted manner. So let's get started. So this is not really a programmatic, pragmatic talk about how you do X, Y, Z with Kubernetes. There are a lot of great technical know-how sessions at this conference, so I thought it would be more useful to talk about our experiences, what we have learned at Apsara, and what you really need to do in order to operate a system like Kubernetes in production. Setting up Kubernetes is often the easier part. The more challenging part is how to support it and how to run it in a production environment. We'll talk a little bit about cloud native infrastructure. And we have spent over 3 years at Apsara solving some of these hard problems around security and trust. So we want to share these experiences with you. It will at least give you the tooling that you need, the concepts that you need to bring the trust in your platform. So let's start at the end. Production environments are all about trust. You don't deploy anything in production environment until you are sure what it is going to do there. And in order to run a system like Kubernetes in a production environment, you need to be able to trust the system. And in order to trust the system, you should be able to answer a few basic questions. For example, what does a workload contain? Nowadays, in microservices architecture, you are assembling the software rather than creating the software. Your container, your workload is containing your application code. It's containing a number of dependencies. It's connecting to a number of services. Can you trust all these dependencies, all the code that makes your workload? Where does a workload run? And it becomes really important in a multi-cloud environment. You may want to run a dev or test workload in one particular cloud environment, and you may want to run production. Can you trust where the right workload is running? Are there right resources to play for the right workload? So as you know, there are multiple containers running in a production environment in a single host. And if one workload is consuming all the CPU, all the memory, all the resources, it's going to starve all the other containers. And the most importantly, can you make sure that the information is flowing in a more secure manner? And the problem becomes much more harder when you try to deploy it on multiple clouds. Try integrating it with a private cloud provider, say OpenStack or VMware. Now for a challenge, throw another public cloud provider, say AWS, GCE, Azure, and so on. Building and gaining the trust over multiple clouds can be a real blast. If I could give you one tool, and just one tool, to build the trust to operate a system like Kubernetes in production, it would be policy. Typically, when we talk about policy, we associate it with a number of boring situations. But in this context, policy as a tool rocks. So what you really want to do is you want to get out of the way of the developers. You really don't want to go and tell developers how to build their applications. You want to have an unopinionated platform where developers can build the application and deploy the applications that they want. But the ops get all the tools, all the platform that they need to be able to run that workload in a secure manner. And ultimately, you want to reduce friction around deployments. I worked at large corporations earlier. I mentioned like I worked at Oracle for over a decade. And typically the policy there around deployments is typically no. If I go back to my IT person and say, hey, Mr. IT, can I get a server to run my application? The answer would be no. Can you add a route to my application? No. Can you please punch a hole in the firewall for my application so that it can talk to another resource on the internet? Hell no. They typically call it a risk aversion policy or enterprise grade security policy. I like to call it a CYA policy, cover your ass policy. But on the other hand, if you look at like the web scale companies like Google and Facebook and others, they allow their engineers and even interns to deploy the applications in production environment without any human intervention. And they don't lose any sleep over it. And the reason they can do it day in, day out, allowing all of these developers to make changes to the production environment, and sometimes on the same server which is running your mission critical ad business for Google, is because they have put enough guardrails in the system so they can make sure that the people are allowed to do the right things without any human intervention, but they are prevented from doing the wrong things. So if you can set the guardrails for the users of your platform that let them do the right things but prevent them from doing the wrong thing, that would be awesome. I was at a cloud conference earlier this year, and it was a large cloud conference, and the keynote speaker, this was a room probably full of 5,000 people. The keynote speaker asked for a raise of hands and said, how many people are using containers in their organizations? And many hands went up. Then the follow-up question was, how many of you are using it in production environment? And a lot of those hands went down. There were very few hands that were still up using containers, Docker containers in production environment. And that kind of reflects the state of the technology where we are. In the last couple of years, we have been talking about cool container technology. We have been talking about Docker, microservices, how to build these applications, and so on. But still, we have not seen all of that momentum translating to running these containers in production environment. And the reason is that there is not enough trust in running these technologies in production environment. And there was a recent Gartner report which even highlights this, that policy evaluation and framework to bring trust to these environments is critical to get adoption for these new delivery models. So let's take a look at what Kubernetes offered today in this direction. Note that I'm talking about the features that come with Kubernetes 1.0 is stable and not any features that's coming down the pipeline. So Kubernetes offers two constructs. It offers you limits on the compute resources, which is CPU and memory. And then it gives you the limits on object counts, which are pods, services, secrets, replication controllers, persistent volume claims. So it's all good. And one big thing the Kubernetes team has done it right is they allow setting these limits on namespaces. And that's really important. We'll come back to it in a minute. Why is it so important? So here are two examples from the doc. Don't know whether you can see it from the back, but the first example shows the quota that is available on the quota example namespace. And you can see in this example that you have quota on CPU, memory, persistent volume claims, pod, replication controllers, resource quota, secrets, and services. So that's good. The second example shows that you can set the default limits on these things, and which is really important because developers by nature, and I've been an engineer too, we are not really good at specifying our needs when we submit the request for the system, right? So the ability to set the limits on the system is really good. For the sake of comparison, let's take a look at what other cloud providers offer. Amazon, you can pick and choose different EC2 instances based on CPU, memory, optimized for CPU, optimized for memory, and so on. You can do security groups, network firewall controls, different network topology. With Microsoft Azure, you can do role-based access controls with 3 set access roles. This Google GCE quote is from their docs, which is essentially if you have added permissions, then you can modify instances and access them using SSH. And if you're authorized as owners, then you can create GCE resources in the project. And if you have ever worked with IBM soft layer, you can control whatever is in their management interfaces using some checkboxes. Last time I checked, there were 70 odd checkboxes, and they kind of change very often. Not most of them are related to policy, though. The bottom line is that every single system out there, whether it's a public cloud or a private cloud, offers its own set of guardrails. And that makes it really difficult for you as an organization to standardize on how you can offer and what kind of guardrails you can offer to your users. And if you're doing it on multiple clouds, good luck. So what do you really need? Ideally, you need 3 things that I call it a policy tripod, because if you remove one thing, then the idea falls over. Pervasive. The policy has to be available everywhere. It has to be available at the resource request time. It has to be available at the workload deployment time. It has to be available at workload migration time. It has to be built in every part of the system. It cannot be pick and choose. Explicit. You should be able to describe what you want and at a granularity level. So for an example, with AWS, you can go and choose from a list of predefined preset instances like M3.small or micro, large, medium, extra large, and so on. You can choose R3 types and the other types. But wouldn't it be better that you can pick from one of these predefined preset types, but also you can specify your CPU, memory, hard disk, and all the other things. So shouldn't you have the granularity to pick from one of these instances or specify your own limits? And the last one is probably obvious to you, but it is really important that not only you can evaluate the policy, but you can also enforce it automatically. If any part of the system is manual, where you have to go to the IT and say, hey, Mr. IT, can you make an exception to this policy, or can you grant me that access, the idea of this new delivery model just falls over. So let's take a look at what pervasive means. So this is the list that Kubernetes gives you today. And this is the same list as we saw before, namely CPU, memory, per instance total, and object counts. Now I added 2 more things that was left out of Kubernetes. The disk space, and disk space is good, but it's not that interesting to me. But the network usage, that's the most important thing in terms of policy evaluation and enforcement, and we'll talk about that a little bit. So let's take the network stuff a little further. So let's talk about how workloads talk to each other. With Kubernetes, we are talking about pod-to-pod communication as well as the communication from container to container within a pod. And just keep in mind that I'm talking about something that you get out of Kubernetes by default. I'm not talking about any additional functionality that you may get from another project, say Project Calico, which offers its own ACLs, which improves the situation considerably. So when you talk about network communication, whether it's between container to container or whether it's pod to pod, many systems offer full connectivity between containers, often by default, which is even worse. So let's take an example. Let's say you have an application which is on 2 containers. One container contains the application code, second container contains the database code. Obviously, they need to communicate, but they don't need to communicate on each port and on each protocol. The container A should be able to talk to container 2 on the database port, and everything else is just a security exposure, because if container 2 gets popped, That means container 2 can attack container 1 in any permissible way. So we were talking about container to container communication within a pod, but how about ingress and egress? Because that's even more important. Should your container be able to talk to every resource on the big bad internet? Possibly, but not likely. At least you want to be prescriptive about it. You want to specify if it can talk to the internet and what it can talk to the internet. Similarly, the external traffic, how it gets routed to the container or the pod. Ideally, you want to be able to map a URL to a container, and you want that mapping to continue to work even if you throw that container to another or workload to another cloud. So switching tracks, so far we have talked about containers, networks, so let's switch tracks, talk about what goes in containers. I believe that policies can help determine what goes in production. So for example, it would be really useful if I can say, use this version of Java in production application, or you can use this version of PHP for the dev and test, but only this version for the production, or retire this version of Go package, but let all the application continue to run that are running in production environment. And this can be really useful. How useful? Heartbleed useful. Wouldn't it be nice to be able to say, this version of OpenSSL is desupported and deprecated. Do not deploy any new application with this version of OpenSSL, and give me a list of all the packages that are running with this version of OpenSSL versus manual audit. When Heartbleed happened, many organizations, they had no idea how many servers, what they are running on these servers, which one is affected by Heartbleed, and it took them weeks and in some cases months to patch their system. So you really want a policy system that can audit it to you, for you, in seconds and minutes and not weeks and months. Similarly, about the deployment pipeline, your engineer has an application ready to be deployed, but as an organization, instead of asking IT for doing a check on a number of things, depending on what your policies are, you probably want to add some automatic checks in your pipeline. For example, you may want to run that application through a malware check before it hits the production, or you may want an workflow to be triggered, or you want an email to be sent out before this application hits the production. So there can be a number of large organization enterprise policies that you can automatically enforce before these applications hit the production. All right, the last one, from less fancy to most fancy. You want to control who has access to the application logs and system logs. And so far we have been talking about this great policy system which allows you to control what goes in the workload, who it can talk to, who can talk to it, what resources it consumes, where it runs. But if anyone can come in and edit that policy, that defeats the purpose of that security. So you want to be able to control who can edit that policy. Think of it as policy for policy. And the last one, operations between front end and back end. And this is really mind blowing. If I can use the policy to control the communication between the front and the back end without front end and the back end knowing about it, that is pretty awesome. So we call it a semantic pipeline. And semantic pipeline sits between the front and the back end and listens into the conversation and can apply policy rules to those conversations. For example, I can say that disallow drop tables. So the application, without modifying any application code, can issue as many drop table statements as it wants, but all those drop table statements falls on the floor instead of tearing down the server. And so you don't have to modify your database, you don't have to modify your application. There is a policy-driven semantic pipeline which is sitting in between and enforcing your organization rules. Another example may be some kind of a circuit breaker, because you have a rogue application which is issuing 1 million requests per second, and you want to have a circuit breaker in terms of semantic pipeline, which controls only let these many requests pass through within a minute or a second. So there are a number of interesting things that you can do with semantic pipeline policy. All right, so we have talked enough about what should go into a policy system. Let's say assume that you have an awesome list of things that you would like to implement as part of the policy system. The question becomes, how do you express these things? And once you have that list, how do you structure those expressions? So the language is really important. So in order to be able to express your list of things, structure your expression, you should be able to specify using a language. Policy is just too hard for humans to understand without using a language. So ask anyone who has used a complex ACL system. Namespaces are important, and again, kudos to the Kubernetes team in introducing namespaces, because with namespaces you can give a sandbox and in a number of different ways to your different teams. And namespaces allows you to organize, whether it's per team member, whether it's per team, per project, per application, per environment. I mean, there are a number of different possibilities that you can structure your projects with namespaces. What would even be cooler if you can do hierarchical namespaces? So you can say /production, /application, /project, /team, /this member. So namespaces are great, but if you can do it based on hierarchical, that would be even awesome. So some of the policy structure tips: make sandboxes, lots of them. By default, we give one sandbox to each user, and that really works out very well. Think really hard about your structure, and don't worry, you will get it wrong first time. So this is something that you have to iterate and improve. And there usually is a tendency to apply policy close to the top of the tree, but that kind of centralizes the control, and then you get back into this, Mr. IT, can I have an exception to that policy? So you will be sad next time you need an exception to that policy. So try to apply policy as close to the leaves as possible. And the last one is just use simple software building principles when it comes to policy. For example, if you are repeating 3 things at 3 places, then the chances are that it is going to be out of sync. So try generating policy automatically if you see yourself repeating things. For example, you can have an automation tool which can import all the LDAP groups and generate automatic policy for you. So a little bit about Apsara platform and tying it all together. So Apsara enables cloud adoption with enterprise-grade policy system. All the great things that I've talked about policy system around the building time, the deployment time, orchestration, Apsara enables all of these scenarios. It provides a single policy-driven system that sits above all clouds, private and public. We support VMware, OpenStack, AWS, GC, Azure, SoftLayer, and so on. And we support running all of the workloads, including legacy application, cloud native application, including Docker images, big data, and so on. So let's bring Kubernetes and Apsara together. Kubernetes provides great abstraction and a great API. Apsara provides enterprise-grade security and policy with support for hybrid cloud and multi-cloud. And this is what we have done with Docker. Docker provides a great tooling, great API for building Docker images. And we can run all of these Docker images, whether it's from public registry or private registry, in a secure manner. We intend to do the same with Kubernetes, where we support for Kubernetes API and abstraction with the Apsara platform that brings the best of both worlds. I have been asked to wrap up. How much? All right. All right, -3 minutes. I'll wrap up now. So,
your mic is gone.
Is it gone?
Yes, your mic is gone. So that's what happens when you go way over time. You're the first person I've ever seen this happen to. It's pretty cool when it happens, though, isn't it? Okay, cool. So what I will do, though, is give you time to do Q&A and maybe explain this last. Well, you won't be able to explain this last slide, but you can tell them about it for about 1 minute while we have the next speaker come up. I will do that for you.
Sure. Sounds good.
All right.
Should I take it?
And do you want to take a question?
Sure. All right.
Is there a question?
We have a booth upstairs, so if you have any question, please come. I will be there. If you have any question, I can take it from there. And thank you for attending.